All right, today we are reviewing what trigonometry is and the basic parts of trigonometry, the beginning. We are talking, and then we're doing a little bit more. So first of all, trigonometry is the study of triangles. And for the most part, right triangles is a major part of the study of triangles. So we talk a lot about right triangles, and you do need to understand the parts of the right triangle. So when I say parts, I mean the hypotenuse is always across from the right angle. And then the opposite and the adjacent here, the opposite and the adjacent, they're dependent upon what angle we're referring to. So there's two acute angles in this triangle. There's one here and one here. And depending on what triangle we're focusing on, opposite and adjacent will change. So for example, if this guy here is theta, and that's the angle, the hypotenuse will of course stay the same. But what's going to change, or what's going to be for this particular problem, between the angle and the right angle is always your adjacent side, and then opposite it, if you can draw an angle to it or an arrow to it, there we are. That's our opposite. So something, if this was your theta, hypotenuse would of course stay the same. This is theta here, so this is the adjacent side. Between the angle and the right angle is the adjacent, and the opposite is the opposite. Shocker. So for example, let's just do two more here. Let's say this is your theta, and this is your theta. Notice that the hypotenuse will always stay the same. So for example, if I did, this one was my theta here, this would be the angle, this is the right angle, so this is our adjacent side, and this is our opposite. But if I then say, switch this around, let's say, oh no, I want this to be theta, the hypotenuse is going to stay in the same place because the right angle doesn't change. But this is the angle, this is the right angle, so now this is the adjacent, and then this is the opposite. So just be wary. Make sure you pay attention to what angle you are talking about when you're doing looking at these right triangles. So this would be the adjacent, this would be the opposite. Okay. Using those, so no matter what you have, if you have the same angles in a right triangle, the sides are always in proportion, and the proportions that we talk about are sine, cosine, and theta. We call them ratios or proportions because there's an equal sign, and these are the opposite and hypotenuse, the sides of the ratios that we're speaking of. So you've talked about this in Algebra 1 and geometry, so just as brief overview here. This is, when we say this is sine. This one is cosine, and then the theta means cosine of theta, T-H-E-T-A. That's how we say it. This is tangent of theta. You always have to have an angle here, because if you don't have an angle, you don't know which one is opposite and which one is adjacent. So without the angle, I don't know what you're talking about. Okay, so make sure that when you do these, you always include the angle in your answers. So let's just do a quick markup of this. We're looking to find sine A, cosine, and tangent, and also of B. So I want to find sine A, cosine of A, and tangent of A. Remember, sine of A is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So if we're talking A here, this is A. So with A, I'm talking this angle. So we can label our OA and H. This is our hypotenuse. This is A, so this is our adjacent. And then opposite it is opposite. So it's pretty easy to write this out. So it's opposite over hypotenuse. This one is adjacent over hypotenuse. And this one is opposite over adjacent. Okay, if we did this with B, all the numbers would change except the hypotenuse would stay the same. So this would be sine of b, cosine of b, tangent of b. So the 5s would stay in their spots, and the 4s and the 3s would all switch. Pretty amazing, right? So the O and the A would change. If we're going to B here, this is the adjacent side. This is the opposite. So when we do this, it's 3 over 5, 4 over 5, and 3 over 4. Okay, fabulous. All right, so what happens when we talk about sides and angles? Please be aware that angles are capital letters and sides are lowercase letters of the sides opposite. So if this is D here, the side opposite is also D, but it's lowercase. So O be this one, and G would be this one. Okay, and that's just for naming of them. So if they're asking for the sine of capital O, this is my angle. So I need to label the OA and H for the sides. So this is the hypotenuse. This is the adjacent side, and this is the opposite side. Okay? Yeah, whatever. So now, it seemed like a happy coincidence that the O was in the O spot. Sine, cosine, and tangent. So if you fill these out, OA and H, so opposite over hypotenuse. This one would be adjacent over hypotenuse, and tangent would be opposite over adjacent. Okay, and they're just the sides, so they're all lowercase letters. So sine of G, cosine of G, tangent of G. Again, the O opposite and the adjacent would switch spots. Okay, because we're talking about G now. So this would be the adjacent, and this would be the opposite. And then when we write these out, it would be G over D, O over D, and G over O. Awesome. All right, we have, those 3 are the ones that you're most familiar with from Algebra 1 and Geometry, but there are 3 more, and we call them the reciprocal functions because, you know, that's what they are. When we say reciprocal, I don't know. Why did this thickness just change? So weird. Anyway, here we go. The reciprocal ratios. So with reciprocal ratios, we flip. So reciprocal just means we're flipping it. It's recognized as 1 over. So sine, well, cosecant is 1 over sine, but that's the same thing as flipping. Because it's, if we were to flip, it would be keep, change, flip, and they would be flipped. All right, so sine, reciprocal. See, this is opposite over hypotenuse, so the reciprocal would be the flip of that. A flip, this guy. So the hypotenuse would be on top, and the opposite would be on the bottom. That's it. They're reciprocal functions. They serve a purpose in this trigonometry, and you're going to learn just the basics of them. So please realize you do have to memorize that sine and cosecant are reciprocal functions. So you say that cosecant. This one is secant, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. That's the easiest one to remember. Otherwise, you do have to memorize this. Some teachers like to say that cosecant is a sine sandwich, so it has sine on the inside of it. So signs in them, I don't know, however you want to do it. I always recognize it by, whatever. I always do it like the S's and the C's go together, so sine and cosecant, cosine and secant, but you just have to find a way to memorize that for yourself. Okay, this is, again, just another way of recognizing that you flip. Okay, that each one is reciprocal of the other. Okay, some basic problems that we're doing here. So we want to find all 6 trig ratios according to t. So this is our angle then. So in other words, I need to find sine of t, cosine of t, tangent of t. Now this is the way I always write it because it otherwise, well, it just makes it a lot easier. So sine, cosine, and tangent are the original. Cosecant is the reciprocal, so I write that next to the sine when I'm writing the answer. Secant is the reciprocal of cosine, so I write that there, and tangent's reciprocal is cotangent. So if I write opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, when I come over to this one, it's just flipping that. There's nothing really to remember. I just have to remember that which ones are the reciprocals, and then I can just flip them. Okay, so to do this problem, we have the opposite, we have the adjacent, we don't have the hypotenuse. So we can fill in all of the, spots except for the hypotenuse spots. Okay, so what we want to do, what you have to do is, we need the hypotenuse. So we have a right triangle, so our most favorite thing, the Pythagorean theorem. So remember, the hypotenuse is always the side that is by itself here. So when the a squared plus b squared plus c equals c squared, this is always the hypotenuse. So we don't know what that is, so we'll just leave it at c squared. We'll fill that in. So that's 5 squared plus 12 squared is 169. Take the square root, and you get 13. Now, we're, of course, going to get radicals here, but I'm just choosing not to put those in right now. Okay, I put those in. Now, if I want to find the cosecant, secant, or cotangent, I just flip them. So 13 over 5, 13 over 12, and 12 over 5. Okay, and then this problem is similar, but our Pythagorean theorem is just slightly different, and they don't give us a triangle. So not giving us a triangle can cause some heartache, and that was a fabulous hypotenuse there. So you can draw it however you want. Whenever I draw it, I always draw my right angle here on the left side, and I put my theta there because that's the way I'm most comfortable. You know what I'm saying? So how do I fill this out? I definitely need a right triangle, so let's think about this. We want to find sine, cosine, tangent. And we know it's sorry, I'm just going to write these out really quick. And then we know this, we need to find cosecant, secant, and tangent. Okay? And those are the flip. Okay, now they gave us one of them. 17 over 8 is secant, so I already know this one. Look at that, look, 17. And 8 is the adjacent side, so that's that. So then I just have to do the Pythagorean theorem to find the opposite side. So I have all the pieces, I have the hypotenuse, I have the adjacent, because that's what secant has, and I just have to do the Pythagorean theorem. So remember, the 17 is the one that's by itself this time, and then that's like a squared if you want to say. Call it whatever you want. So this becomes a squared plus 64 equals 289. Subtract the 64, and I get a squared is 225. Take the square root, and when I take the square root, I'm only taking the positive because we're talking about length here. And this is 15. So now I'm just going to switch colors so it's a little more obvious. Sine, this is our opposite. This is our adjacent. This is our hypotenuse. So opposite is 15 over 17. This one is 8 over 17. This one is 15 over 8. And then we just flip. 17 over 15. I mean, I guess we could have just flipped here to get that one, but whatever. 8 over 15. There we go. I hope you understand. We'll do some problems like this. Have a great day.